Assalamu alaikum. Today we are going to start exercise 3.3. Question number 1 is find the value of unknown when two order pair are equals to each other. Part number 1 is if the element of first order pair are a and minus b and second are 7 and 1 and they are equal to each other, then find the value of unknown that are a and b. Number 1, if a and minus b equal to 7 comma 1, then find the value of a and b. Since two order pair are equal to each other, so in this case first element is equals to first element of the second order pair and the second element of the first order pair is equal to second element of the second order pair. So we can write here a equals to 7 and minus b equals to 1, which give the value of b as minus 1. So these two are the values of unknown a and b. Similarly, in second part, the first element of the first order pair is 2a and it equals to the first element of the second order pair, that equals to minus 10. Solving this, we get the value of a. 2 is divided with a, multiply with a and divide on the other side with 10. So the answer of a is minus 5. Now comparing second element of first order pair with the second element of the second order pair, we get the equation 2b plus 3 equals to minus b. Here we combine the values of b and separate the constant. Two b plus 1b equals to 3b, which equals to minus 3, and b equals to minus 3 over 3. Dividing, we get the answer minus 1. So the two unknown value is a is equal to minus 5 and b equals to minus 1. So in third part, the first element of the first order pair is 2a minus 4. It equals to the first element of the second order pair, that is 8. So the equation becomes 2a minus 4 equals to 8. Here we combine the constant 4 and 8. 4, we added 4 on the other side of the equation. 8 plus 4 equal to 12. 2 and a are multiplied to each other, so 2 is divided on the other side of the equation. So the answer of a is 6. Now comparing second element with the second element of the both order pairs, so we get the equation 6 equals to minus b plus 1. Here again combine the constant. We get the value of 6 minus 1, that equals to 5, and the value of b equals to minus 5. In 4 part, we compare the first element with the first element of both order pair. X plus 2y is equal to the first element of the second order pair, that is 2. It becomes equation number 1. Now comparing second element, here y minus 3 equals to 5. So from equation number 2, we find the value of y, that is y minus 3 equals to 5. Combining constant, 3 we come add on the other side, so the answer of y equals to 8. Now put the equation of y in equation number 1 to get the value of x. Put value of y in equation number 1. It becomes 8 2s are 16. Now again combining the constant term, 16 become minus on the other side of the equation. So the value of x is minus 14. Value of two constant x and y are minus 14 and 8. In fifth part, the two equations become comparing first element with the first. It become 2x minus y equals to 4. And the second become y minus 3x equals to 2. Now to solve the simultaneous linear equation, first we have to make the coefficient of any of the variables same. First we rearrange the second equation, that is minus 3x plus y equals to 2. Rearrange 2. Here you can see the coefficient of y is already same with the opposite sign. So solving these two equations, adding equation number 2 and 3. Plus 2 and minus 3 equals to minus x, that equals to 6, and the value of x equals to minus 6. Now put the equation of x in any of the equation. I put the value in second equation. 6 3s are 18, minus minus plus. So here value of y is 2 minus 18 minus 16. In 6 part, first element 4x plus 6y is equal to 6. So equation become 4x plus 6y equals to 6, equation number 1. Second is x minus 12y, second element is equal to second element of this order pair, x minus 12y equals to minus 3. This is the second equation. Now we have to make the coefficient of any of the variables same. So for this we multiply equation number 2 with 4. Multiply 2 with 4. We get the equation 4x minus 48 equals to minus 12. This is equation number 3. Now subtract 3 from 1 equation. What we get, 4x plus 6y equal to 6, 4x minus 48y equals to minus 12. Subtracting, change the sign of the equation, these are cancelled to each other. 6 plus 4 equals 6 plus 48. So here 6 plus 48 equals to 52. Y equals to 6 plus 12 is equal to 18. So value of y equals to 18 divided by 52, which by cancellation 2 9s are 18, 2 2s are 4, 2 6 are 12. Sorry, 6 plus 48 equals to 54. So dividing with 2, 2 2s are 4, 2 7s are 14, 9 1s are 9, 9 3s are 27. So value of y equals to 1 by 3. Now put the value of y in any of the equation to get the value of x. I put the equation value in second equation. Put the value of y in second equation. Here we get x minus 12y equals to minus 3. X minus 12, 1 by 3 equals to minus 3. 12 and 3 are cancels with 3 table. 3 1s are 3, 3 4s are 12. X minus 4 equal to minus 3. Minus 4 is add on the other side of the equation. So the value of x equals to 1. Now solving the last part, here compare the first element 5x plus y equal to 6. Equation number 1 is 5x plus y equal to 6. And equation number 2, second element minus x plus y equal to 1. Here the coefficient of the variable y is same on both equations. So we subtract equation number 2 from 1. Subtract equation 2 from 1. 5 plus 1 equals to 6x, 6 minus 1 equals to 5. The value of x is equal to 5 by 6. Now put the value in any of the equation to get the value of y. I put it 1, equation number 2. Put in equation number 2.
So here we put the value of x in equation number 2. It become minus 5 by 6 plus y equals to 1. And minus 5 by 6 is add on the other side of the equation. 5 by 6 plus 1, and the final answer of y is 5 by 6. Taking LCM, it's 11 by 6.
Question number 2 is A set element equals to 148 and B equals to 10. Then find the cross product of AB, then B cross A, then A cross A and B cross B, and also write the total elements in A cross B, B cross A cross A and B cross B. So first we find the cross product of A cross B. So we find A cross B, write the elements of A 148 multiply with elements of B 1 cross 0. So we first multiply the first element of A with all elements of set B, then make pair of second element with all pair of B and the third element with all pair of B. The first order pair is 1 1, second is 1 0. Then the pairing of second element of A with all elements of B, which is 4 1 4 0, and then 8 with 8 1 and 8 0. So the total number of order pair in A cross B are 6. We write it as total elements in A cross B equal to 6. Second part is B cross A. So first we write the element of B set, that equals to 1 0, and then write the element of A set, that are 1 4 8. Making order pair, first multiply the 1 with all element of A set and then make pair of 0 with all element of the A set. So making pair of 1 with all element of A set is 1 cross 1, 1 comma 4, 1 comma 8. Now make element of pair of 0 with all element of A, that is 0 1, 0 4 and 0 8. So counting the number of elements, that are 1 2 3 4 5 6. So the total elements in B cross A also equal to 6. Now we find the cross product of A with A. Write the elements of A cross A, that are 1 4 8 multiply 1 4 comma 8. Now making pair of first element 1 with all element of the second set and then 4 and 8. So making pair of 1 with all three elements, that is 1 comma 1, 1 comma 4, 1 comma 8. Now we start making pair with 4. So it's 4 comma 1, 4 comma 4 and 4 comma 8. Now start with making pairing with 8, that equals to 8 comma 1, 8 comma 4 and 8 comma 8. So the total elements are counting 1 2 3 4 5 6 7 8 9. So we write it as total elements in A cross A equals to 9. In last part we have to find the cross product of B cross B, which equals to, write the element of B 1 0 multiply with 1 0. Now making pair, first we are making pair of 1 with the other element 1 and 0, that is 1 comma 1, 1 comma 0. Now making pair of 0 with these two elements, that is 0 comma 1 and 0 comma 0. So the counting number of element in B cross B, total elements in B cross B equals to 4. Question number 3 is, let E equals to element 1 3 and F equal to set of element 4 6 8. Then express these cross products graphically. So here first we find all the cross product and then we express them on graph paper. First we find E cross F. E cross F equals to cross product of elements of E and F, 4, 6, 8. So that equals to 1, 4, comma 1, 6, comma 1, 8, comma 3, 4, 3, 6, and 3, 8. Now we find the cross product of F and E, that equals to 4, 6, 8 multiply 1 comma 3, and that is equals to 4 comma 1, 4 comma 3, 6 comma 1, 6 comma 3, 8 comma 1, and 8 comma 3. Third one is the cross product of E cross E, that equals to 1 comma 3 multiply 1 comma 3, 1 comma 1, 1 comma 3, 3 comma 1, and 3 comma 3. And the last one we have to find cross product of F cross F, that equals to 4, 6, 8 multiply with 4, 6, 8. So here the order pair are 4 comma 4, 4 comma 6, 4 comma 8, 6 comma 4, 6 comma 6, 6 comma 8, 8 comma 4, 8 comma 6, and that equals to 8 comma 8. Now we represent all the order pairs of these cross product on graph. So here we first plot the order pair 1, 4. Here 1 is on x-axis and 4 is on y-axis. So combining these with scale we get the point this, which is of 1, 4. Similarly we plot all the order pair on the graph. So this is the final representation of all the order pairs in graph. The black points represent all the plotting of the corresponding order pairs in graph X and Y. Question number 4 is, if L cross M product is given as these order pairs, then find the set LM and the cross product M cross L. Here L cross M cross product is given as these order pairs, so we have to find the number of elements of set L. So set L consider all the elements of the first element of all order pairs. So we write all the first element of each order pair, that are 0 and 1. So these are the elements of set L. Set M equals to all the elements of each order pair's second element, all the second element of each order pair, that are 2, 3, 4. So the elements of M are 2, 3, 4, and we have also find the cross product of M cross L. Here the cross product of L cross M is given, so to find the cross product M cross L we change the position of X and Y element. If we interchange the position of X and Y element, then we get the cross product of M cross L. So it equals to, first order pair is 0, 2, now it become 2, 0. Second is 3, 0. Interchanging the position of X and Y, now it is 4, 0, 2, 1, 3, 1, and 4, 1. So here we find all the elements of the set LM and M cross L. Now question number 5 is that, given that the set A with the element 1, 3, 5, B with element 2, 4, and C with element 6, 7, find the first part, that is cross product of A with B union C. So in first part, cross product of A with B union C, first we find B union C. B union C mean all elements of B and C are included. So we write it as 2, 4, 6, 7. Now cross product of A with B union C equals to, write the element of A 1, 3, 5 with cross product with the elements of B union C 2, 4, 6, 7. So in cross product we make pair of first element with all the elements of second, and then second and third. So first we make pair of 1 with all element of the second set B union C. It is 1 comma 2, 1 comma 4, 1 comma 6, 1 comma 7. Now we make pairing with 3. It's 3 comma 2, 3 comma 4, 3 comma 6, 3 comma 7. Now making pair with 5, 5 comma 2, 5 comma 4, 5 comma 6, and 5 comma 7, which is the required cross product of A and B union C. In second part we have to find the union of the two cross product A cross B and A cross C. So first we find A cross B. Write the elements of A and then write the element of B. So cross product equals to 1 comma 2, 1 comma 4, 3 comma 2, 3 comma 4, 5 comma 2, and 5 comma 4. The cross product of A cross C equals to, write the element of A and C. So this cross product is equal to 1 comma 6, 1 comma 7, 3 comma 6, 3 comma 7, 5 comma 6, and 5 comma 7. Now we find the union of these two cross product. Union mean write all the element of these two cross product. So we write all the elements. First one is 1 comma 2, 1 comma 4, then 1 comma 6, 1 comma 7, 3 comma 2, 3 comma 4, 3 comma 6, 3 comma 7, 5 comma 2, 5 comma 4, 5 comma 6, and 5 comma 7. So these are all the order pair that are included in union of A cross B and A cross C.
Now we have to verify the third part, that is a cross product of A and B union C, that equals to union of the cross product of A, B and AC. As you can see in first and second part, we find both left and right hand side of part third. So from 1 and 2 we can see that the answer contains the same 12 elements. So it is verified from first and second part. The third verification done. Question number 6 is given that D set with element A, E, I, E with AC and F with BC. So verify the first part, that is a cross product of D and E intersection F. So first we find the intersection of E and F. Write the element of E, A comma C, intersection with element of F, B comma C. As you can see, the only common element is C. Now we find this intersection cross product with D. Write the element of D set A, E, I, multiply intersection element, that is only C, that equals to AC comma EC and comma IC. So this is the first part answer. The second part is find the intersection of the two cross product D cross C and D cross F. So first we find the first cross product D cross E. Write the element of D set A, E, I cross element of E, A, C. Taking cross product, first we pair A with the second all element of second set, that is A, A, C. Now pairing E with the other element E, A, E, C, and with I, A, I, C. Now taking cross product of D and F, write element of D. Now cross product of D cross F, write the element of D and F. Now pair A with all element of F, that is AB, comma AC. Now pair E with element of F, EB, EC, and IB and IC. Now we find the intersection of both the cross product. First we write the element of D cross E intersection with D cross F. So here you can see the common elements are, first common element on both set is A comma C. So we write it as A comma C. Second is EC, E comma C, and the last one is E comma I comma C. Now in third part we have to verify the cross product of D and E intersection F, that should be equals to the intersection of both cross product DE and DF. So as you can see in first part we find D multiply E intersection F. So elements contain AC, EC and IC, and in second part we find the intersection of cross product DE and DF that also contain AC, EC and IC. So we can say from 1 and 2 part we already verified that
In question number 7, given that the set A in set builder form x such that x belongs to natural number and x is less than 3, b x y such that y belongs to whole number and y is less than 2, and c equals to 0, 2, 4, verify the first property a cross b minus c equals to a cross b minus a cross c. So here we first write the element in set form here x such that x belongs to natural number and x is less than 3. So natural numbers start from 1. Number of elements in A are only 1, 2. In B it belongs to whole number and less than 2. So less than 2 whole number are 0, 1, and C elements are 0, 2, 4. So to verify it we first consider the left hand side, that equals to A cross B minus C. First we find B minus C, write the element of B. So we write the element of B that are 0, 1, and the element of C that are equals to 0, 2, 4. Subtracting B from C, so we only get the one element 1. Now taking cross product of A with B minus C, write the element of A that equals to 1, 2, and taking cross product with 1, that is equals to 1 comma 1, 2 comma 1. This is the left hand side answer. Now we find the right hand side. Right hand side equals to A cross B minus A cross C. So first we find A cross B, cross product that equals to A 1, 2 and B is 0, 1. Taking cross product we get answer 1 comma 0, 1 comma 1, 2 comma 0 and 2 comma 1. Now we find the cross product of A cross C, that equals to 1, 2 multiply with 0, 2, 4. This is equals to 1, 0, 1, 2, 1, 4, 2, 0, 2, 2 and 2, 4. Now subtracting second cross product from first, that equals to A cross B minus A cross C. It means we write all the elements that are remain in A cross B when subtract it from A cross C. First we write the element of A cross B, that equals to 1, 0, 1, 1, 2, 0, 2, 1, and then write the element of A cross C, that equals to 1, 0, 1, 2, 1, 4, 2, 0, 2, 2 and 2, 4. So by subtracting, as 1, 0 is on both, same order pair on both sets, so we don't write it 1 cross 1 comma 1 is not on the second set, so we write it 1 comma 1. 2 comma 0 is same and 2 comma 1 is not there, so we write it 2 comma 1. So this is the right hand side answer. So from left and right hand side, this is the left hand side answer, which is equation number 1, and this is the right hand side answer, which is equation number 2. From 1 and 2 we can say that left hand side equal to right hand side, and verify verified a cross b minus c equals to a cross b minus a cross c.
So here we verify the second part, that is considering left hand side a minus b cross product with c. So first we find the difference of a and b set, write the element of a set element 1 2 and then b element 0 1. As 1 is on both the sets, so it is cancelled to each other and only 2 remain in a minus b. Now find its cross product with c set. We write the element of c set, that equals to 0 2 4, and pairing become 2 0 comma 2 2 and comma 2 4. So this is the left hand side answer. We call it equation number 1. Now we find the right hand side. First we find the cross product of AC, then BC, and then subtract each other. Cross product of A cross C contain the order pair 1 0, 1 2, 1 4, 2 0, 2 2, comma 2 4. And cross product of B cross C contain the order pair 0 0, 0 2, 0 4, 1 0, 1 2, 1 4. Now we subtract B cross C from A cross C set as 1 0. So we cancel the same element that are in both set as they are subtracted to each other. So the set contain only element 2 0, comma 2 comma 2 and comma 2 comma 4. As you can see that 1 0 is on both sides, so it cancel to each other. 1 2 comma 2 is on both sets and 1 comma 4 is on both sets, so they are cancelled to each other. So only set contain element 2 comma 0, 2 comma 2 and 2 comma 4. So this is equation number 2, and from one equation and two equation we say that we verified left and right hand side are equal to each other.
Last question number 8. There are two sets given in set builder form, and we have to represent these cross product by arrow diagram. So in last part we have to show it by arrow diagram. So first we write the cross product of x cross y, that equals to 0 minus 1, 0 minus 2, 0 minus 3, 1 minus 1 minus 1, 1 minus 2, 1 minus 3, 2 minus 1, 2 minus 2, and 2 minus 3. Now we represent all the order pair in arrow diagram. So in last part we represent the cross product by arrow diagram. So first we plot 0 minus 1. 0 is with minus 1, this arrow, and then 0 with minus 2, and 0 with minus 3. Now 1 with minus 1, 1 with minus 2, and 1 with minus 3. And the last one is 2 with minus 1, 2 with minus 2, and 2 with minus 3. Similarly on the second one, first minus 1 with 0, minus 1 with 1, and minus 1 with 2. And in second one, minus 2 with 0, minus 2 with 1, and minus 2 with 2. And the third one is minus 3 with 0, minus 3 with 1, and minus 3 with 2. So this is the arrow diagram of both the cross product. I hope you will understand the whole exercise 3.3. If you like it, please like, subscribe my channel and share with your friends. Thank you.